In the last lesson, we implemented the database. Now our frontend is ready to showcase the data coming from it. But what remains is the backend that will facilitate the connection between the database and the frontend. So let's create that backend API, a waiter in a restaurant between a chef and a customer. We can do that by creating a new folder called routes within the source folder in the backend part of the application. And then within the routes folder, create a new subjects.ts file. Within it, you can define a new router coming from Express, and then define the route by saying router.get, where you're going to get the request and the response. I don't think it's needed to heavily type them right here, so you can just define the request and response like this. This route will get all subjects with optional search, filtering, and pagination. Perfect. So to implement it, we can first wrap it in a try and catch block in case something goes wrong. We can simply console.error, and we can be descriptive about it, saying get/subjects error, and then we can render the actual error right here. And don't forget that we also have to return something. Specifically, we're going to return a status of 500 that's going to bring back a JSON object that says error and then failed to get subjects. This way, if something goes wrong, we know exactly where it went wrong. Now, remember when I told you that we are doing some filtering and search on frontend, but our backend at that point wasn't yet accepting those props? Well, they are coming here. So let's destructure them. We get the search prop, the department prop, the page, which we can set to 1 by default, and the limit, which is going to be 10. And all of these are coming from rec.query. Then we can get access to the current page by saying current page is equal to, and we need to ensure that the page number is at least 1. So I'll say math.max 1, and it's going to go all the way up to the limit, so plus limit. Then we need to ensure that the limit per page, like this, is at least 1 as well. So that's going to be math.max 1, and then plus limit. And this one here was supposed to be plus page. So it's going to be at least 1, but it can potentially be the page number that we pass into it. Same thing for the limit. Then we need to figure out the offset. That is how many records to skip to get to the next page. We can do that by getting the current page minus 1 times the limit per page. Then we'll define an array to store the filter conditions. So say const filter conditions is equal to an empty array. Now, if a search query exists, we want to filter it by subject name or subject code. We can do that by saying if search filter conditions dot push, so we're pushing additional conditions, we'll use the OR functionality coming from Drizzle ORM, as well as the I like, also coming from Drizzle ORM, where we want the subjects, which are coming from our DB schema, dot name or dot code, to match the thing that we have in the search. Okay, so if search query exists, filter by subject name, or this is that or by subject code. Then we want to do the same thing for the department. Right below, I'll say if department filter exists, match the department name by pushing the additional condition departments.name. So make sure to import the departments coming from our schema. Now we can collapse those two. Finally, we want to combine all filters if they exist using the AND operator. Again, this AND is coming from Drizzle. Then we need to get the count of all the elements on the page. So that's going to be count result is equal to await db dot select. So specifically, we want to get access to the count, which is going to be SQL number, and then we want to specify the count of all the elements. This SQL part is coming from Drizzle ORM, and it allows you to run native SQL queries. Specifically, we want to get the count from the database, so make sure to import this db, and it'll be coming from /db at the top if it doesn't get auto-imported. So we are selecting that right here. After we select it, we also want to take it specifically from the subjects table. So it's going to be from subjects. Then we want to apply something known as a left join. So dot left join, where we want to join the departments table as well. Specifically, what a left join does is it returns all rows from the left table and the matching rows from the right table. So we want to take all the data about the subjects, but we also want to get access to the department ID, so subjects.department ID, where it matches the ID of a specific department. So departments.id. And we have to get access to this EQ operator coming from Drizzle. And finally, we want to say where and where it matches the where clause, which are our filters. That's going to give us access to the total count by saying count result 0 question mark dot count, or if it doesn't exist, we'll make it default to 0. And then we want to query the data. We can do that by saying const subjects list is equal to await db.select, and we want to select the spread of get table columns. And this is coming from Drizzle ORM, to which we need to pass the subjects. So what get columns does is it gets all the columns of that specific table, but it also adds additional columns that you want to add. So in this case, we are getting all the columns from the subjects, but we also want to add the department column where we will spread get table columns for the department as well. And I will put this into multiple lines so it's a bit easier to see, just like this. And here we pass the departments. Now I'll put this into a new line just so we can see it a bit better. And to this select, I will chain dot from subjects dot left join. And here we want to attach the departments. Specifically, we want to attach the subject's department's ID, where the department ID matches the one attached to the subject. We want to attach the where clause. And we also want to order it by. So dot order by, it's going to be in descending order. So make sure to import that from Drizzle based on the subjects dot created at. We want to limit it to the limit per page that we had. And we want to offset it by a specific offset. I know this was a long query, but this will give us the data that we need. It's going to contain both the subject's data as well as the department's data. So now let's return it by saying rest.status of 200 and then .json. And now we can format that data in the way that we want, such as data will be the subject's list. And then for the pagination, we can pass additional information such as page, which is going to be set to the current page, the limit, which is going to be set to the limit per page, the total set to the total count, and then finally we can pass the total number of pages, which is going to be math.ceil of total count over limit per page. Perfect. And this is now a query that will return all of those subjects with the department data attached, and also at the same time allow for querying, filtering, and pagination. So now let's go over to the source index.ts and let's create a new router for the subjects by saying app.use. It's going to be /API /subjects, and we'll pass in the subjects router that we just created. Not the subjects coming from the schema, but rather the subjects router, which we needed to export from here. So I'll say export default router, and then we can refer to the router we just created, but we can rename it to subjects router because later on we'll have some additional routers as well. This is coming from routes subjects. And again, make sure that it is actually exported at the bottom by saying export default router. And now if you open HTTP and create a new request, let's see whether it's working. We want to point it to 8000. That's where our backend is hosted, /API /subjects. And of course, let's make sure that our backend is running by running npm run dev. Oh, looks like we're importing DB in routes subject, but we cannot find it there. So let's make sure it's coming from the right place. DB, it is being exported, but let's make sure that it is exported in the right way. We can export the DB right here, not the index. If you do it like that, it'll be able to properly recognize it. Let's see if that is the case. We're using the DB right here. So we can say DB, and then at the top, we can say import DB as a named import. And you can see if I type D, it's directly coming from here, and it is correct. So now the server is running on localhost 8000, and we can try to make a request. And take a look at that. We get back the data with a couple of subjects. We have subjects with ID of 5 and 6. It's signals and data structures, having specific code, having the description of the subject, but also having all the necessary information about the department that that subject belongs to. So now we can very easily extract additional information about the department. And we also get some additional information about pagination, such as the page we're on, the limit, and the number of total documents. We can also try seeing if search and filtering works. So for example, if we do !, search is equal to, well, let's do signals. It should be able to give us just this one and not the one with data structures. So if I do search, you can see that we get back only 1, and the pagination data has fixed. What if we try to get the information for the second page? By setting the page to 2, you'll see that there's no data to show on the second page. Pretty cool, right? And finally, if we also try to fetch the data by department, by setting it to something like, well, what do we have? I forgot. I'll leave it empty for now. Department name is electronics and communication. So maybe if I just start typing electronics, it should be able to find it, and it actually finds both because the department for both is set to electronics. Wonderful. Now, you can follow this same exact template of sorting, pagination, and search for rest of the API endpoints, like getting a list of departments, classes, users, enrollments, whatever it is. The process will look exactly the same with a tiny bit of changes on the main data query where you might want to join some tables. But I suppose you already have a pretty good idea of how it works. Okay, great. Now, before we use this API on the front-end side, we have to enable Course. Remember at the start, I was telling you a bit about how Course works. Browsers block front-end apps from calling APIs hosted on different origins. And without explicitly allowing the requesting origin to be able to make calls, the browser will refuse responses before our server code even runs. Enabling Course tells the browser which origins, methods, and headers are safe to use so the client and server can exchange data securely. In practice, setting Course is vital for modern apps where the UI is often served from a different domain than the port on the backend. So to set it up, you can simply head over to your terminal, make sure that you are still on the backend. So that's going to be classroom backend, and run npm i course. Then let's install the types for Course by running npm i --save -dev at types/course. Now within our backend code, not frontend but backend, head over to your env file, and below the database URL, add a frontend URL so that it knows who it is talking to. It'll be equal to http://localhost 5173. And don't add an additional / at the end. Keep it like this. Then go to our server file, which is the index, and right here below the port, define Course by saying app.use course. Provide additional options, such as the origin, which we're going to set to process.env frontend URL. This is going to be the React app URL. And then add the methods that will allow, such as the get, post, put, and delete, and provide additional credentials by saying true, which simply allows for cookies. And make sure to import Course coming from the new package that we just installed called Course. And that's it when it comes to course. So now that we have added these changes, let's go ahead and push it over to GitHub. Before I push it, I'll pull the latest changes. Oh, and we have to make sure that we're on the right branch. So do a git status. It seems that we're currently still on the database schema branch, which for now is still okay. So what I'll do is I'll run git add dot git commit -m implement get all subjects route and run git push. This will push the changes over to GitHub, and you'll see that we have some recent changes 4 seconds ago. I'll open up another PR. This one only had 6 little file changes, mostly the file where we actually created this additional route. The rest was the setup. So this should be super simple for CodeRabbit to go through. All faults understood. Let's give it like literally half a minute, and I believe it'll already prepare a code review for us. If you take a look at the walkthrough, it's clear that we introduced core support, as well as added a subjects API endpoint with search, department filtering, and pagination, as well as applied updates to the Drizzle configuration to reference this new schema. What I love about walkthroughs is that we're also getting sequence diagrams. And I think this is the first time in the application where it actually makes sense to start seeing one. So you can expand it, and this explains exactly what we'll focus on next. The client, in this case the browser, will make a GET request to the API subjects API. It'll provide optional search parameter, department, and page params to our Express application, which will then process the request through the course middleware. It'll validate it, and only once it's validated, it'll speak to our API subjects, which will then speak to our database, getting the count, selecting the needed things from the database, joining the rows, and then finally return that data over to the frontend. This is a beautiful diagram explaining exactly what we have implemented and the flow of our application. So let's scroll down and let's see whether we have some fixes. Okay, this is potentially a big one. It's a critical issue where we need to update the schema path to reference an existing schema file. The path index.subjects.ts does not exist. I don't even remember making this change. Maybe it was done by my IDE automatically when I was renaming files. So again, this catch is absolutely huge. I can't even imagine that we have this mistake directly within our code right now. But hey, it looks like it's here. So this is incorrect, and instead, it should only be pointing to the index. So remove the subjects. Huge catch. Then we have another one, potential issue, major. Validate frontend URL environment variable for security. The course configuration uses it without validation. If it's undefined, the origin will be undefined, which will result in an error or a security vulnerability. So the proposed fix is to add a simple if statement, which we can do right here at the top of our index.ts file, where we can check if process.env.frontend URL doesn't exist. We can then simply throw a new error. I like this. Then we have some validation and maximum limit enforcement. The current implementation has 2 issues. If not numeric values are passed, plus page or plus limit will produce not a number, and math max 1 will return not a number, which leads to invalid SQL queries. Interesting. So we definitely have to apply the fix right here, and the fix is to properly parse integers. So let's go ahead and copy these changes and paste them over right here where we have our subjects route, where we're doing the number count up. We will remove these 2 lines and instead add the 2 new ones that are properly parsing the numbers without resulting in not a number in edge cases. There's another one, which is critical. SQL injection vulnerability in department filters. Okay, the department parameter has the same SQL injection vulnerability as the search filter. User input is directly interpolated as the SQL query without proper escaping. This is huge. So what we need to do is escape specific patterns. So I will copy these 2 additional lines, head over to where we have the department query, and I'll paste them right here. Let's make sure they're properly structured. There we go. And this will protect us from SQL injections. Soon enough within this application, we'll also implement ArcJet, which will take an even deeper dive into protecting us from all sorts of different attacks. But the fact that CodeRabbit was able to catch this SQL injection vulnerability is a huge plus. And finally, the last issue is a syntax error. Interesting. There's a syntax error in line 51, okay, where a stray period dot appears before the order by. Oh no, it's not a mistake. It was supposed to be on line 52, but it's just here. So the only change we have to make is just add it at the start of the line and not at the end. Okay, it's not gonna break anything, but I agree it is a bit weird. So we'll just take this dot from here and put it right here. Okay, overall, very, very valid feedback and code review done by CodeRabbit. So let's go ahead and implement those changes by running git add dot, git commit -m, implement suggestions from CodeRabbit, and then git push. Once that is done, you can merge the pull request because we know it's good and safe. And then back within our application, you can switch back to the main branch and pull all the latest changes by running git pull. That way, we have a clean slate to continue working on the application. Because in the next lesson, we'll dive straight back into frontend so we can consume the backend API we just created.